Okay, good morning, guys. Today I want to have a look at sine, cosine, and tan graphs and their reciprocal graphs, so the graphs of cosec, cot, and sec. In order to do that, we want to sort of remind ourselves about the unit circle. All of those graphs relate back to the unit circle and what happens with the unit circle. So remember, a unit circle is a circle that has a radius of 1. And we're looking at what happens to the points as that radius basically moves around and forms that circle. So we're looking at our x-coordinate and our y-coordinate. Now, if you remember back to earlier this term and also when you did your year 10 work, our x-coordinate is related to our cos coordinate and our y is our sine. So we're basically having cos and sine as it moves around the circle. So here we've got an angle of 0 degrees. So our radius sits on the x-axis. If I move that slowly, you can see that as our angle theta gets bigger in that first quadrant, we're moving up till we get right at the top to 90 degrees. And what's happening up there? It's really hard to get it spot on. Let's see if we can move it exactly to 90. We've got it nearly there. There we are. When we're at the top, we've now got a 0 for our x or our sine and a 1 for our cos. And we can keep spinning that around, and I'll pop this link into our OneNote, so you might want to go and have a look at that as well. What we're going to have a look is what happens to our sine and cos curve, or how our sine and cos curve are formed as we move around that unit circle, and that's what we're going to have a look at now. Here we have our sine curve. It's moving around up and down here. It's fluctuating between 1 and minus 1. We think back to our unit circle. Our unit circle was 1 in length, 1 in length. We had minus 1, minus 1. So they relate directly. And we've got our degrees at the side here. We've got 90, which relates to our angle here. We've got 180, 270, and 360. Now let's have a look at what happens as we move around that unit circle. So when I'm at 0 degrees, when my theta is 0 degrees, which is where we are here on our sine curve, let's think about what happens. Our x-coordinate is our cos, our y-coordinate is our sine. So we want to think of the y-coordinate and think about what this point would be called on our unit circle. It would be the point 1, 0. So 0 is our y, which is our sine. So at 0 degrees, we're at 0. Watch the point move around the sine curve as I move around the unit circle. This is what's happening until we get up to the maximum value up here of 1. 1 happens at 90 degrees. Now what happens on our circle here? Our radius is 1. We are at the point now 0, 1. Okay, so we want that second coordinate, which is our y, which is our sine. So at 90 degrees, sine is 1. Okay, so let's have a look now what happens when we continually move around that circle. Watch the angle and watch what happens on that sine curve. Our angle's getting bigger and we're moving down till we get down to 180 degrees on our unit circle, and then we're also at 180 degrees. We'll try and sit at exactly on 180. I can't quite get there, 179.95. It's very particular. But we're down here. We're at 180, and we're at 180 on our unit circle. Okay, remembering x-coordinate is cos, y-coordinate is sine. We want the y-coordinate. Our point out here is sitting at the point minus 1, 0. So at 180 degrees, our y value is 0. On the sine curve, our y value is 0. Likewise, let's move again to 270. All the way down there. Look at what happens on the sine curve. And we've hit 270. We're down the bottom. We're looking for the y curve. Not the y curve, our y point. Our point is 0, minus 1. Remembering sine is our y point. Sine is minus 1. And our value here is minus 1. We're nearly 1 rotation through the unit circle. Let's go back up. We're going to hit 360 degrees. As close as we can get to 360 on that unit circle, we're going to get just about there. And we have met 360 degrees on our graph. Okay, so at 360 degrees, we are at the point 0, minus 1 or 0, 1 we're thinking of here again, aren't we? Because we're back to where we started. So we're back to our first point here in the same spot again. Our sine value is our y is 0, and we're at 0 degrees. So what we're saying is that curve, that sine curve, repeats itself every 360 degrees. And we would call that a period. So the period of our sine graph is 360 degrees. That's where it reoccurs. Another thing that we actually have on our curve here is our value from 0 up to our highest point, which is 1. We call that height there, that value of 1, an amplitude. So the amplitude of our sine curve is 1. It has a period of 360 and an amplitude of 1. We've got x-intercepts, cuts the x-axis at 0, 180, 360, and the same in the other direction. We haven't had a look at the other direction yet, but we're also continuing that graph in the negative direction. So we'd also have x-axis intercepts at 1, minus 180, minus 360, and so on. And that will continue on depending on how many revolutions we're wanting to go around that unit circle. Okay, we're going to have a look at the cosine curve now, which we generally call the cos curve. I'm just going to have a look at it in the positive axis, but it will also continue on in the negative direction. You've got a diagram of that on your workbooks, and we'll have a little bit more of that, what happens in that negative angle as well. Okay, so just like the sine curve, the cosine curve relates to how we move around that unit circle. The difference here is with the cosine curve, we're looking at the x-coordinate because our x-coordinate relates to cosine. And so in this case, where our sine curve started at 0, we're going to have our cosine curve starting at 1 at 0 degrees. Because our point here at 0 degrees is the point 1, 0. 1 is our x-coordinate, 1 is our cosine coordinate. So we have an amplitude up to 1, and that's where we start. As I move around that circle, we're going to get, as the angle increases, our theta gets up to 90 degrees at the top. And what it does when we reach that 90 degrees, oops, I'll get it exactly on if I can, it crosses our axes. Pretty close there. At 90, it's going to cross our axes here, and it's going to be at 0. So we look at what happens when our value is at 90 degrees, which I can't exactly get mine to match up on my diagram. We'll see. Oh no, there we are. We're just about there. We've got a value of 0, 1. Our x is 0. That's our cos. So at 90 degrees, we're hitting 0. Likewise, we're going to have a look at what happens to the sine curve as I move around. As my angle gets bigger and I get down to 180, I'm going to be, here we are, looking at minus 1, 0 as my point. Minus 1 is our x, minus 1 is our cos, and we are at 180, and so our point is at minus 1. Okay, now we've moved up to 270. 270 degrees is down here on our diagram. We are looking at 0, minus 1. Cos is the x value, cos is 0, so at 270 degrees, we're at 0. We've got one more movement we can go till we get back to our starting point, moving all the way up to 360 degrees. When we hit 360 degrees, we are again sitting at 1 because we're back to our starting point, which was up here, and that's identical. So what we've got here is the period of our graph is 360 degrees. That's where it repeats itself. It's going to continue in that positive direction. It's also going to continue in the negative direction, and we're only going to be restricted by our domain. Here we've got our domain between 0 and 360. So remember, domains are x values. Okay, so I've only put this in between 0 and 360, but we will be looking at different domains as well. Let's have a look at our tan curve now. Okay, so if we think about what's happening with our tan curve, we need to know what tan is first. So remember, tan theta is sine theta on cosine theta. Our sine was our y coordinate, and our cos was our x coordinate. And as we move around our unit circle, we're going to cross points at 0 degrees, cross axes at these. What we're going to relate to are our points 0, 1, minus 1, 0, 0, minus 1. So what we're going to find is we're going to be dividing our y by our x. So for example, when we get to 90 degrees, we're going to have 1 divided by 0. 1 divided by 0 is an error on your calculator, or what we normally call it is it's undefined. So when we come to that on our tan graph, we're going to get something called an asymptote. It's a point that is undefined where our graph can't exist or can't cross. And the same is going to happen at 270 degrees. So let's jump across to the tan curve now and have a look. Okay, so I'm just going to start this. It's going to show us what happens as we move around the unit circle. Okay, so we've moved up to 90 degrees and our tan curve has moved into this strange shape, sort of like half a parabola. But what happens is, remember I said at 90 degrees we're going to divide by 0? This little part here, pi on 2, we're going to have that represents 90 degrees. We're going to have a little look at these values in terms of pi, but that's 90 degrees. That is an asymptote. That's undefined on our calculator, and that's where our graph cannot touch and can't occur. So what our graph will do, it will get really, 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 really close to our asymptote, but it will never, never, ever touch it. Let's restart that and have a look as we move around further. Okay, so we've moved now from up the top. We now have moved down the bottom. We've crossed the axes at 180 degrees. And remember I said at 270, we're going to have another asymptote because we divide by 0. 270 is over here. So let's have a look at what happens as the graph moves towards there. Okay, so the graph gets to 0. It flips in the other direction. And again, at 270, we can see it's not going to ever touch that. And it's going to continue going up towards that asymptote, but never, ever, ever touch it. Let's restart that and see what happens in the last section. Okay, so it's going to continually repeat itself. We've got up to 360. We're obviously going to have another asymptote over here, and it's going to continue again. I'll let that go for a little bit further. And we can see that there's more asymptotes. Our graph, in this case, continually moves along that line. When it gets to the top, it's going to then get to a value where it's going to jump us back down to the bottom. Okay, so that's our tan curve. So when we're dividing by 0, when our y divided by x or our sine divided by our cos has our cos or our x value being 0, we're going to get vertical lines called asymptotes. Now those are marked on your graph. Our tan graph continues in the positive direction, and it will also continue in the negative direction and continue on. And it will just depend on whether or not we're looking at our a particular domain or a particular range. We've been concentrating on our domains between 0 and 360, but we are going to be moving around that more and more. Into different domains. Okay, now where our sine graph and our cos graph had periods of 360, where it repeated every 360 degrees, what you can see here is we are having a smaller period here. So our graph repeats itself every 180 degrees when it's a tan curve. So this part here is repeating back over here at 180. So that's our period. Okay, so you need to be able to quickly sketch these graphs for Year 11 Advanced Maths. You're very familiar with the unit circle, so you should quickly be able to sketch a sine, cos, or tan graph yourself. I'll pop this one up and then we'll have a look at another video for the reciprocal graphs as well.